are going to discuss about centroid or center of gravity and simple problems related to centroid. So, let us discuss first what is meant by center of gravity. Center of gravity is nothing but it is a point through which the whole weight of the body acts. A body is having one center of gravity for all the position of the body. It is denoted by CG which means center of gravity. Whereas for centroid, which means the point at which the total area of the plane figure like rectangle, square or triangle is assumed to be concentrated is known as the centroid of that area, and it is also denoted by CG. Center of gravity is denoted by CG and centroid is also denoted by CG. Then what is the difference between center of gravity and centroid? Center of gravity for 3D objects, whereas centroid for planes, 2D objects, right? The methods for center of gravity. So, we can determine the center of gravity or centroid by three different ways. One is by geometrical consideration, another one is by moments, and the last one is by graphical method, right? So, now center of gravity by geometrical considerations. So, we know that how to find the centroid for the plane figure, maybe a rectangle. So, we have to divide the length and height, then the center point is called as CG, or joining the diagonals AC and DB, then the intersection point which is called as CG, centroid. Or if the plane, if this rectangle is a plane, then it is a centroid. Then if this is the 3D object, then it is a centroid, right? Whereas for triangle, so we have to join, bisect the sides and joining from each corners, right? So, A from A we have to divide this BC, divide by 2, or bisect this side BC, then we got point D, then join AD. Similarly, we have to divide or we have to bisect the side AC and we got E, then joining BE, right? So, the intersection point is called as CG, right? The center of gravity of the triangle is at the point where the three medians of the triangle meet, right? So, now how to derive the formula for center of gravity by moments method, right? So, what we discussed, that is geometrical consideration. Now, we are going to discuss about by moments method, right? So, let A be the total area whose center of gravity to be determined. So, this is the picture. We want to calculate the CG of this total ellipse, right? So, that is A. We need to find the CG of this particular area, right? A small A1, A2, A3 or the small areas, we have to divide this total area into small areas. This is A1 and this is A2, A3 and A4 respectively, right? So, this is a small area A1, similarly A2 is there, A3 is there, right? So, A1, A2, A3 etc. are the small areas, right? Then capital A, the total area which is equal to sum of all the small areas. Let x1 be the distance of the CG of the area A1 from the OY axis. So, x, which is the distance between the center of gravity of the small area A1 and the reference axis OY. Similarly, x2 which is the CG of A2, the distance between A2 and the OY axis. Similarly, A3, similarly A4, right? The first moment of area A1 about the OY axis, which is equal to distance into CG, that is x1, the distance between the CG of the small A1 area and the OY axis into area, right, A1. Similarly, the moment of all the small areas about OY axis, which is equal to sum of all this A1 x1 plus A2 x2 plus A3 x3 etc., etc., right. So, the moment of all the small areas about this OY axis, which is equal to A into x bar, total area into x bar. I mean, this is the CG of the total area and the distance between OY axis and the CG of the total area, which is called as x bar, right. So, A x bar, which is equal to sum of all the moments of all the small areas about OY axis, right. Then x bar, which is equal to sum of all this divided by A, right. This is x bar. Similarly, we have to find y bar. So, y bar, which is equal to, instead of x bar, from y directions, which means the CG, the distance between CG and OY axis, right. So, this is CG and this is the distance y bar, right, from OX axis, right. So, y1 A1 plus y2 A2. Similarly, we have to do what we did in x bar axis. Okay. So, this is the two main formulas to find x bar and y bar, right. X bar, which is equal to A1 x1 plus A2 x2 plus A3 x3 etc. divided by sum of all the small areas A1 A2 A3. Similarly, y bar, right. This is the few examples. This is the plane section or plane area and the formula for area and what is the formula for x bar and y bar, right. See, take for example rectangle, the breadth which is equal to b and height which is equal to this. How to find CG? CG which is equal to b divided by 2 and h divided by 2, right. So, this is for x axis x bar and this is for y axis y bar, right. So, similarly, few examples are there. And center of gravity of symmetrical sections. Sometimes the given section whose center of gravity is required to be found is symmetrical about x axis or y axis. If in such cases the procedure for calculating CG of the corresponding body is very easy, we have to calculate either x or x bar or y bar, right. If the given section is symmetric about x axis, then we have to calculate x bar. If the given section is symmetric about y axis, then we have to find y bar, right. So, this is due to the reason that the center of gravity of the body will lie on the axis of the symmetry, right. So, now let us solve a simple problem. Find the center of gravity of 100 mm into 150 mm into 30 mm T section. We have to find the CG of this given section, right. So, this is the picture and first we have to draw the axis, right. So, this is y axis and this is x axis, right, y axis and x axis, this is O and this is x and this is y, right. So, we have to divide this given section into two sections. And this is first section and this is second section, right. So, two rectangles are there. One is the first section. The first section is A, B, C, H and second section is F, E, G, D, right. So, what is the formula for this given section is symmetric about y axis, right. So, this is the y axis and this given section is symmetric about y axis. So, we have to find only y bar. What is the formula for y bar? Y bar which is equal to A1 y1 plus A2 y2. Only two sections are there, that is why A1 A2 divided by sum of A1 plus A2, right. So, section 1, first we have to find the section 1 A, B, C, H. First we have to consider this section 1. So, we have to calculate A1 which is equal to, what is the formula? L into B, L which is equal to 100, B which is equal to 30, right. So, L into B which is equal to 100 into 30 which is equal to 3000 mm squared. Similarly, y1 which is equal to what? Y1, which means this is the CG, right, and this is y1 which is equal to the distance between CG of the corresponding section into the the distance between the CG of the corresponding section and the axis of OY, right. So, this is y1. So, up to this what is the distance? 150 minus 30 which is equal to 150 minus 30 which is equal to 120 mm. So, up to this 120 mm, then 30 divided by 2 which is CG, right. 30 divided by 2 which is equal to 15. So, 120 I mean 150 minus 30 plus 30 divided by 2 which is 120 plus 15 which is equal to 135 mm, right, 135 mm. Similarly, now take section 2 FEGD, right. So, now we are going to calculate A2 L into B which is equal L which is equal to how much? 150 minus 30 which is equal to 120, this is 120, the distance between this which is equal to 120 mm, right. So, 120 into 30, right. So, 120 into 30, right. So, 120 into 30 which is equal to how much? 120 into 30 which is equal to 3600 mm squared. Then how to calculate y2 which is equal to this 120 divided by 2, right, which is equal to 120 divided by 2 which is equal to 60 mm. Now, substitute the values y bar which is equal to A1 how much? 3000 into y1 which is equal to 135 plus how much this? A2 which is equal to 3600 into y2 60 divided by sum of A1 A2 3000 plus this is 3600. So, what is the value of y bar? Y bar which is equal to, first we have to calculate numerator 3000 into 135 which is equal to 405000 plus 3600 into 60 which is equal to 216000 divided by 3000 plus 3600 which is equal to 6600. So, what is the value? 405000 plus 216000 divided by 6600 which is equal to 94.04 mm, right. So, y bar which is equal to 94.09 mm. So, this is the value. Let us check 94.09. Yes. So, this is how we have to solve the problem. So, next one is find the CG, find the center of gravity of a channel section 100 mm, 50 mm and 15 mm, right. So, 3 sections are there. This is section 1 and section 2 and section 3, right. So, this section is symmetric about x axis, not y axis. So, first we have to calculate. So, we want to calculate x bar. X bar is enough because CG is lying on the x axis somewhere, right. So, first section which is equal to first section 1 which is equal to JFAB or ABFJ. Second section 2 which is equal to KGJE. Section 3 which is equal to CDKH, right. So, x bar, what is the formula? We know that x bar which is equal to x1 A1 plus x2 A2 divided by 3 sections. So, x3 A3 divided by sum of the areas A1 plus A2 plus A3. First we have to calculate section 1. Section 1, what is the formula for A1? L into B, right. So, 50 into 15 into 15 which is equal to 750 which is equal to 750 mm squared. Similarly, x1 which is equal to, so first we have to draw the axis, right. So this is O and this is x and this is y. So section 1 from O, this is CG of this section. So what is the distance? 50 divided by 2, right. So 50 divided by 2, which is equal to 25 mm. Similarly, we have to calculate section 2, area 2, which is equal to, this is section 2, and what is this is 15 and this is also 15, right. So 15 plus 15, 30, 100 minus 30, which is equal to, what is this is 70, right. 70 into thickness 15. So 70 into 15, right. 70 into 15, which is equal to 1050 mm squared, and x2 which is equal to, what is the distance of CG, which is equal to, this is 15 divided by 2, 7.5 mm. Similarly, section 3 is this, what is, which is equal to 50 and this is 15, the similar A1, right. So A3 which is equal to 750 mm squared, and x3 which is equal to 50 divided by 2, right. CG of this is x3. So 50 divided by 2, which is equal to 25 mm, right. So substitute the values. So x bar which is equal to 25 into 750 plus x2 which is equal to 1050 into 7.5 plus x3 which is equal to 750 into 25, right. So divide by A1, A2, A3, A1 which is equal to 750 plus A2 which is equal to 1050 plus A3 which is equal to 750, right. So now x bar which is equal to, what is the value? First we have to calculate numerator, 25 into 750, which is equal to 18750 plus 1050 into 7.5, which is equal to 7875 plus 750 into 25, similar value 18750 divided by sum of this 750 plus 1050 plus 750, which is equal to 2550, right. So now x bar which is equal to 18750 plus 18750 plus 7875 divided by 25550, which is equal to 17.79 mm. So x bar which is equal to 17.79 mm, which is actually the CG of this section is lying on 17.79 from this OY axis, right. So let us check the answers. 17.8 mm, right. Thank you.